Hello. How we doing? I need to post the notes so that way you guys can follow along if you'd like. So I'm going to do that live right now. Because why not? Let's go ahead and add this module. And add notes. Download the 1.4 notes. Save. That's okay, Slow Turner. You can, if you want, you can catch the replay, or you can just follow along now. It's up to you. I'm gonna go ahead and edit the name for printable notes. Indent. We'll give this a header. For quadratics. Quadratics. Okay. So I'm going to go ahead and publish that. So if you're watching right now, the notes are now printable. Do you want to print them real quick? Sorry, I didn't have those up there right away. That's my bad. I didn't realize I didn't add this module before I started the stream. And then I should probably go ahead. Probably should go ahead and make a new quiz for the live stream assignment. Way you can do that. So live stream assignment. I'll hit edit on this. Live stream assignment is the name. That 1.4. Hopefully we'll get a few more people watching here after I'm done with this. If you're already tuned in now, I appreciate you. Graded survey 0. And then we'll add a due date of tonight. So everyone knows it's there. And then we need to add a question. Question says only survey, and then I have watched options. Whoops. Question saving here to the modules, and I'll add this assignment. There we go. Indent. Perfect. Okay. So should we go ahead and get started? Is anyone else here in the chat with me? No? Nobody's here? KT. What's up, my guy? Or my girl? Kind of hard to tell. All right. KT, if you have any questions anytime, let me know. If anyone else is out there, just let me know if you have any questions. Slow Turner is still there. Awesome. So, right about here. I'm a little tired. Let me get some energy here. I'm a girl. Okay. Like I said. Let me get a little energy. Right about here is where we're starting the 1.4 notes for Algebra 2. If you're watching the replay, hello. Don't forget to submit the live stream assignment 1.4 to let me know that you watched it. And the few people that are in the chat right now, KT and Slow Turner, you can do that too when we're all done. But let's jump right into it. We've been graphing quadratics, these parabola looking things, right? The U. And we've seen a couple different forms for our function. We've seen vertex form, which looks something like, that, right? And we've seen intercept form, which was our most recent one, which looked something like, what were the letters? Q and P? Doesn't really matter. They're just generic. I think Q and P, right? Yeah, Q and P. Which looks like that. Now we have this standard form, which is this guy right here. Play Valorant. I potentially could play after this. I'm not gonna lie, I haven't played in a while. That sounds kind of fun. So maybe I will. So that's standard form, ax squared plus bx plus c. Standard form is you see it quite often, but it's actually my least favorite of all of them because when I look at it, I feel like it tells me the least amount of info. If you recall from vertex form, it obviously tells us the vertex, hk. In intercept form, it obviously tells us the intercepts, q and p. With standard form, there's really not a lot of information that's staring us in the face immediately. A, B, and X don't tell us a whole lot right away. However, we can use A, B, and X to solve for these things right there, okay? We can solve for these guys using these equations. We can find the axis of symmetry using that equation. We can find the vertex, right? And we can find the Y-intercept. However, it requires maybe a little bit more work instead of just it obviously staring us in the face. What's up, Andres? Hey, we respect Darblaz. Don't give him a hard time. So, when we look at this equation in standard form, let's identify A, B, and C. That's pretty easy to see. We can see A, B, and C right there. So, what do A, B, and C tell us? Well, we can use B and A to find the axis of symmetry. There's that equation right there. So let's find the axis of symmetry. The equation is negative B over 2A. So what is B? So negative 8 all over 2 times A, which is 2. So the two negatives make a positive, which is 8, and 2 times 2 is 4. So 8 divided by 4 is 2. So what that means is our axis of symmetry is at x equals 2. So when I look at this equation, I don't immediately know that, right? It's not like I look at that and go, oh, I know immediately that the axis of symmetry is at 2. I have to use this equation, but nonetheless it works every time, which is nice, okay? And we solved it to be 2. So, what are the coordinates of the vertex? Well, something that we mentioned it was a part of my Socrative quiz from last class is that the vertex we know has to be somewhere along this axis of symmetry, okay? So that means the vertex is 2 comma something. Okay, does that make sense? I know that the vertex is either here at 2 comma negative 9, or maybe it's up here at 2 comma 8, but nonetheless it's 2 comma something. Okay, so what is that something? How do I figure out the something? Well, all you have to do is plug 2 into the function. That's what this is saying right here. So when you find a vertex, this is the equation for the axis of symmetry, okay? The h value of the vertex always matches the axis of symmetry. What we don't know is the k value, okay? And we need to solve for that by plugging in the number 2. So let's plug it into our function. 2 times 2 squared minus 8 times 2 plus 6. So I get 2 squared is 4, 4 times 2 is 8, minus 16 plus 6, which is 8 minus 16 is negative 8, plus 6 is negative 2. So the vertex is at 2 comma negative 2, right there. So once you find the axis of symmetry, what did we do right here? I'll write a little note so that way those of us live and those of us watching the replay just plug in the axis of symmetry to find the vertex. That's all we did there. So at this point, I know that the vertex is opening upwards because I still have this a value, right? If a is equal to 2, we know it's stretching and it has no flip, right? So I know it should look something like this. Okay? We know that much, and I should probably make it a little skinnier because it's been stretched, yeah? So it looks something like that. But we also know one other thing. The Y-intercept is equal to C, okay? So what is C? 6. So our Y-intercept is 0, 6. So we know immediately that there's a point right here at 6. That's just something that we know right away. That's of all, I said at the beginning about standard form that when I look at standard form, there's not a whole lot that I know right away, right? With vertex, I immediately know the vertex. With intercept form, I immediately know the intercepts. With standard form, I immediately know the y-intercept. Thanks for the follow, Andres. You're learning math. Appreciate you. So I immediately know the y-intercept. That's the one thing that I do know. So there it is. And with that being said, if I know the y-intercept is at 6, I know that there's another point symmetrical on the other side right there. Because that's just the nature of parabolas. They're symmetrical. Okay? So let's finish this off. Boom. There is our lovely parabola. We're going to do this a couple more times. Probably don't need to do it too much, right? I don't need this video to be too long because that's all we're covering, right? Everything is still I don't want you to think anything that we've seen from the past is any different, right? Parabolas still have the same behavior. They still stretch and shrink, all that. Ooh, thank you, Hout AKG. So I don't want you to think that there's anything different about this. It's just a different form, right? We can have it in vertex form. We can have it in intercept form. Now we have it in standard form. but in the end, they all produce a parabola. Okay? So I want you to realize too that you can always, don't forget that you can always just plug your graph into Desmos to double check. Okay, hide behind the chat over here now. But I just want you to see what I'm plugging in here. The equation was 2x squared minus 8x. Oops, didn't mean to click down. That's my bad. Plus 6. So you can see here that there's that vertex at 2, -2. And there's that y-intercept at 0, 6. There's the one that's symmetrical on the other side. It's exactly what I just did. But, just double checking. Yeah, like, do you have to graph these by hand? No, you can always just plug them into Desmos. But sometimes it's nice to know some of these facts off the dome, instead of having to always plug it in, right? You should ideally be able to look at this and know two things right away. It's been stretched because of the 2, and there's a y-intercept at 6. Those should be some things that you start to know immediately when you see something in standard form. Okay? So with that being said, what are the 2 things that I should immediately know? And there's some of us in the chat, and you want to help me out? It says here that I have 11 viewers right now. What should I immediately know about this function? We have negative x squared plus 2x plus 5. Anyone? I'll give you a few seconds here to reply in the chat. I know there's a slight delay. What are the 2 things I should know right away? Perfect. Slow Turner there said in the chat, y-intercept is at 0, 5. Exactly. I immediately know that the y-intercept is 5. And then visually speaking, where is this graph going? There's another somewhat telling detail here. It's not an exact point, but like, how is the graph behaving? There's something that's sort of affecting the graph a little bit here. All right, we're not seeing it right away, and that's okay. The negative is telling us that the graph is flipped. Right? I think that's worth noticing as well. So I'm using the equations that are given from above. I'm rewriting them over here to the left. So first off, the axis of symmetry can be found by doing negative b over 2a. And you can tell I already took the time to write down my a, b, and c. Okay, so let's go ahead and do that. Negative b over 2a. So negative 2 over negative 2 in the end, which is 1. So my axis of symmetry is at x equals 1. Okay. And because I now have that axis of symmetry, I know that this thing is symmetrical. So if the y-intercept is right there at 5, I now know that the other point's on the other side. I couldn't plot that one yet because I didn't know where the axis of symmetry is. But now that I know where the middle is, I can easily have this symmetrical graph. So now I know that the graph, because it's opening down, it's going to look something like this, right? So we know the vertex isn't going to be somewhere down here. That's not going to make any sense, right? The vertex is going to have to be up here somewhere in order for this thing to open downwards. So let's figure out where that is. And as I said, all you got to do is plug in that value. Thanks, Darblaz. All you got to do is plug in that value. So let's do it. I don't have a lot of room here, so I'm going to do it off to the side. Negative 1 squared plus 2 times 1 plus 5. Again, why am I plugging in 1? I plug in whatever I found the axis of symmetry to be. So that turns out to be 2 plus 5 is 7, minus 1 equals 6. So the vertex is right there at 1, comma 6. And now I know what the rest of this graph looks like. Let's go ahead and have it open. Not going to do yellow, not a great color to use right now. Let's just do orange. This thing's going to open downwards like so. There's a couple other follow-up questions just to we can still ask these other questions, right? Domain, range, max, min. Because this thing is opening downwards, we can clearly see that we have a max, and that max is at 6. That's probably pretty obvious to most of us at this point. And domain, I've said it a couple times, and I'll say it again right now. The domain for parabolas is always all reals, right? This graph is going to continue to go to the left as it goes down, right? It's obviously going to the left, and as it goes down here, it's going to the right. It's going forever, so domain is all reals. And then the range is the y values. So let's take a look and get rid of these arrows. Let's take a look at the y values. We always go from small to big. So this graph is going down, 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 all the way down to negative infinity. And then as it comes up, the highest it goes is boop, right there at that max, right? So it goes all the way up to 6. And I used this bracket because it's including the 6. I'm literally touching it right there, right at the top. I'll donate $100 if you do the WAP dance. All right, donate $100. Negative infinity exists. Yeah, I mean within reason, right? It's not a number that I can touch or own or have, but it is a concept that exists. Uh, let's do one more of these guys, and then we'll do this one that's kind of involving a bit of a word problem. How do you find the max or min? It's whatever the highest y value is, or the lowest y value. So the max slash min is the highest, or biggest, should I say biggest? Biggest slash smallest y value. So this graph has a maximum because it has a tippy top, right? It doesn't just keep going up, 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 up. It hits a point where it stops, so we call that the maximum value, and said maximum value is 6. If this were the other way around and graphed something like, I don't know, this, and there's the vertex, it's obviously going infinitely up. So what we care about is where does it bottom out, right? We care about where is the peak slash where is the valley, so to speak. So the lowest possible value in this case is, or smallest, is -8. So we'd say the min is at -8. What about when there's if there's no a b, if there's no numbers? That's a heck of a question, Slow Turner. If there's no a, b, or c, then you don't have an equation on your hands. There's nothing in front of you. There's literally nothing, right? There's 3 numbers, a, b, and c. If you don't have any of them, then I guess you're looking at nothing. Or am I misinterpreting your question? Did that help you out, KT? So which one should we look at? I mean, I could probably graph both of these pretty quickly. I'll just speed it up a little bit. So A is, so again, when you're looking at this equation, it's ax squared plus bx plus c. So if there's one missing, then said value must be 0, right? I'm adding nothing. You don't bother writing 0 in this case because you just don't have to. That's just how math works, right? We can leave off things if we want. So in this case, we're not adding anything. So we say it's just, but nonetheless, there is a number there, even though we can't see it. A in this case is 1, B in this case is -6, and C in this case is 0. I can toss another thing at you. What if I had 6x squared minus 2? In this case, A is 6, B is 0, right? There's no bx, there's no middle term, right? There's only the whole number that's at the end. That's honestly something that students do make a mistake on, is they think it always goes A and then the next number has to be B. I mean, yeah, the next number is B, but we just can't see it, right? So A is 6, B is 0, C is -2. So the x squared term is A, the one with just x is the B term, and the one that's just the constant is the C term. So we have no constant, therefore C is 0. Okay. Glad I could clarify that for you. So axis of symmetry is negative b over 2a. So b is -6, so -6 all over 2a. A is 1. So the two negatives cancel. We have a 6 divided by 2 is 3. So perfect. We have an axis of symmetry at 3. 1, 2, 2, 2, 2, 2, 2. Okay. So there's my axis of symmetry at x equals 3. The vertex is somewhere along this axis of symmetry, so we simply plug in the axis of symmetry, and I'm going to do that over here just so I don't have to cram it. So off to the side here, I'm going to plug in 3. So 3 squared minus 6 times 3, that's 9 minus 18, that's -9. So our vertex is at 3, -9. 3 because that's what I plugged in, and -9 because that's what the output was. So voila, we have a vertex at 3, -9. Thank you, Lysol survivor. I'm glad you're surviving, Lysol. I don't know what it's doing to you, but I'm glad you made it out alive. And if there's the C value is the Y-intercept, so in this case, there is no C value. Well, there is. It's 0. So the Y-intercept is at 0. Boom. Up there. And we know that it's symmetrical. So 1, 2, 3 to the left. So there's another one. 1, 2, 3 to the right. And at this point, we have just about everything we need to draw a pretty decent graph. There it is. The min is that lowest value, which we can clearly see is at -9. Let's skip zeros for a second and do domain and range. Domain we know is all reals. I wrote all reals before, but a fancy script R means all reals. And then the range is always small to big. And if you haven't caught on yet, right, the range and the min/max always play a role with each other, right? So in this case, the lowest we can get, the min, we already wrote it down, -9, and then from there, we're going up, 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 up. Our zeros, well, in this case, we plotted the zeros. You realize that? The zeros is a word from last lesson. It's wherever the graph crosses the x-axis. And we can clearly see that it's crossing the x-axis here and here. So we ask ourselves, where is it crossing? It's crossing at 0, and it's crossing at 6. So at 0 and at 6. So I'm going to write at 0 and 6. And again, if you ever question yourself, or maybe you were like, crap, I can't see the zeros very well, and you don't want to take a guess. Again, we're in this online state. You know, we all have our computers in front of us. You know, sometimes in class this wasn't always possible. That's honestly an advantage of being online, is that we're all sitting in front of a device that we can use Desmos really easily on. You can see the zeros are at 0 and 6. And you can see the vertex, we can just confirm we plotted it right, at 3, -9. So we did it right. There's our pretty parabola. Again, I encourage you to do that every time. I encourage you to plug it into Desmos every time. What are my thoughts on NBA 2K21? Never been a 2K guy. I know a lot of people like that game, but like that series, but never been. I'm a FIFA guy myself. I like FIFA. I don't play regularly, but I do like it. Let's do this super quick. A is 1, B is 8, C is 10. Watch how quick this can be. Negative B over 2A, we get -4. I plug in -4, and I get -4 squared plus 8 times -4 plus 10. I get 16 minus 32 plus 10. -16 plus 10, that's -6. So I know my vertex is at -4, -6. I see that C value. I immediately know the 0 is at, or the Y-intercept is at 10. So let's go ahead and write that down. And let's go ahead and plot what we already know here. So I have an axis of symmetry at -4. Okay, there's that. And I know my vertex is at -4, -6. So right there. I know this thing is opening upwards and going to cross at 0, 10. Right there. And right there. And then I'm just going to go ahead and graph this. Like so. We have a minimum value. You can see it has a smallest point at -6. Let's skip the zeros for a second, because that's not exactly obvious. Let's do domain. We know that's all reals. And the range, like I said, the min and slash max and the range are very intertwined, right? So the smallest we can get, -6. We already said that. That's the min, and then it goes up from there up to infinity. Perfect. Okay, so the zeros. You might look at this and go, well, it's pretty close to like -2-ish, right? Like, I mean, my sketch is very quick, right? I mean, how much can we trust my super quick sketch? I mean, we can trust it somewhat, but again, like, we have Desmos in front of us. Let's just do it. I know you can't see me typing right now. I'll show it to you when I'm done typing. But let's just do that, you know? If we want to know the zeros and we want to know exactly where they are, let's just go ahead and plug it into Desmos. So I plugged it in, and you can see it's not quite at a pretty value. It's not, right? I mean, my drawing wasn't half bad, but it's not crossing at a particular spot. So that is going to happen sometimes, right? It's not like parabolas are perfect and cross at whole numbers only, right? That's not a thing, right? Whole numbers are rarer than you might think, okay? So I'm going to write in words, and this will definitely be an option on the quizzes. You'll see stuff that's written in words, between, I'm going to say between, let me go back to my graph. What are we between? On this half, we're between -1 and -2. And on this side, we're between -6 and -7. Again, the 0 is where it crosses the x-axis. And yes, there's like an obnoxious decimal there, but decimals is rounding. It's not like the decimal just ended at 3 digits, right? It's probably this really long, obnoxious decimal, and it happens to be rounding. So we're just going to say between -1 and -2 and between -6 and -7. So let's go ahead and write that. Between -1 and -2 and between what did I say? -6 and -7. Andres, I'll answer your question in just a half sec. Let me ask something to all of you. How do we feel about these three or four whatever examples that I did? Is there a part that's tripping us up that we should focus on in this last example, or do we feel comfortable? There's a bit of a delay, so as you type that out, just let me know I'm good, or let's use the chat. I encourage you. It says there's 12 of us watching. Let's just let me know how you're doing. What games do I like? I do like Valorant. I know that's kind of like mainstream right now, but I do like Valorant. I like CS:GO. I like FIFA. Single player games. I don't know if you've ever played it, but Alan Wake is probably my all-time favorite single player game. Assassin's Creed. Haven't played any of the new ones. I haven't played Assassin's Creed since Assassin's Creed 3. Confident. Great. Okay, perfect. And there's a few more of us watching, but if we aren't using the chat, that's fine. But that's kind of a taste of my games that I like. A manufacturer. So here's the last one, and then we can hang out afterwards if we want. So a manufacturer of lighting fixtures has daily production costs modeled by blah. I'm not going to bother saying all those decimals. Where Y is the total cost in dollars and X is the number of fixtures produced. Sketch the graph of the model. Label the vertex. So I know we have Desmos as a tool, but I think we should practice one more time. Let's find the axis of symmetry. I have all this blank space down here, so I'm going to use it. Let's find the axis of symmetry. -b, so -10, all over 2a, so 2 times 0.25. So I have 10 divided by 2 times 0.25, so that's 0.5. So 10 divided by a half is 20. So the axis of symmetry is at 20. Okay. Where is the vertex? Well, as we know, we have to plug in said number, 20, in order to find the vertex. So 0.25 times 20 squared minus 10 times 20 plus 800. Pull out a calculator if you need it. Desmos has a nice scientific calculator if you go to desmos.com/scientific. So I've got 0.25 times 20 squared minus, so 100 minus 10 times 20, I don't need to do that, 200, and then plus 800 is, negative 100 plus 800. I don't really need to do that either. Is 700. So the hard part was this, probably 400 times 0.25. So what did I just say? 700. So the vertex is at 20, 700. So let me switch up the color. There. And then we know that the Y-intercept is at 800. So that means our graph looks something like that. And it's a bit, well, actually, let me plot the symmetrical one. So 1, 2, 3, 4. 1, 2, 3, 4. So it looks something like that. And we know that because of the 0.25, we know it's wide. And clearly it's wide, okay? So there's our sketch. There's the vertex. So check, we did that. What is the minimum daily production cost? So let's take a second to absorb what it is that we're looking at. Y is the cost. That's the y-axis. And X is the fixtures. So if you're unfamiliar with lighting fixtures, it's lamps, okay? All right, it's lamps. All right, so when we make 20 lamps, that's where the vertex is. That's the minimum amount, okay? That's the minimum production cost, 20 lamps. If we make 20 lamps, it's like the cheapest, okay? Why is cost going down right here as we make more lamps? Well, if you ever ordered anything, if you order in bulk, you tend to get a better rate, right? So there's lots of things that go into the production of a lamp, and apparently if they make too few, they probably aren't ordering enough supplies, and so therefore they're paying like a higher price if they are only making a handful of lamps. But if they make 20 lamps, well then they're kind of like maximizing their profits. So what is the minimum daily production cost? $700. So how many fixtures could be produced each day to yield a minimum cost? Well, I just gave away the answer by saying that we're making 20 fixtures. Right? When we make 20 fixtures, that's the sweet spot, right? Why is cost going up as we make more? Well, that's because we're having to buy more supplies. Right? But so 20 is the sweet spot. But clearly, as you make more, you have to spend more. But hopefully, at that point, you're also making more of a profit. Okay. And this is something, a lot of students tend to ask, like, well, when am I going to use this? Or, I mean, we can model this cost profit situation here, and kind of we can find this sweet spot for this company to let them know what their production rate should be, right? If you make too little, you're here. If you make too much, well, you might need to outsource or find a new supplier or something like that, right? There's a sweet spot to everything, and if we can model that with a function, right, and prove that to the team, right, prove that to the employer, then we can all work together and make some money. And with that being said, live stream people, replay people, we have finished the notes. Don't forget to do the live stream assignment 1.4 to let me know that you watched. Let's see. I can play some games, but I have to end the stream so that way I can produce the replay. If I don't end the stream, the replay will not be produced. So if you actually legitimately want to watch me play some games, I can end this stream and then restart it. That sound all right? I don't know if whoever cared about me playing games is in here, but I can. Close Desmos over here. This. Get rid of this. But thank you for watching. And nonetheless, I'm going to end it so that way the replay gets produced. But I'll keep an eye on chat. So, thank you. See you in class.